Hey Adam and Andrew, this is my video of me explaining my code. I don't know if you guys I know Andrew, I saw your email. You said you had problems like downloading it from GitHub, which is weird. I thought I used it right, but I'll go back and like fix that later on after I send this video to you guys. But yeah, if you haven't already downloaded or figured out how to download it and run it in processing, this is what it looks like. And you can press any key, literally any key, shift, any letter, number, tab, enter to change the colors and make a random color palette. And another cool thing is if you left click, you can make the colors lighter. If you right click, you can make them darker. But yes, now let's get to the actual code. So up here, right here, we're declaring the initial colors of the rectangles when we're first starting out, and with all these integers right here. Sorry, I'm a little sick right now. And then right here, this P image, we're declaring our image, or the only image I'm using is the actual Quick Palette logo. So that's the one you see, the logo right down here, the white rounded rectangle right here. Then we have our void setup. Here's the size, 1280 by 720. Set the frame rate. I set a frame rate for this to help prevent the flickering from when you press a key or you hold a key down to make something cool. Then we're loading our image or the Quick Palette logo. Then we're onto our draw, and pretty simple, black background. Then we have right here our first rectangle. We're filling with the random R, G, and B, and we're setting the same height and width for each rectangle. Basically, the rectangles are all the same size, or just all placed next to each other. So that's all we have right there. And here we're actually drawing the logo after we load it. And I saw some of your comments, Andrew, and I'm gonna update this code so we can save it. Right now, I put it here for right now, like the actual function. But I realized that I'm using the right click's being occupied by like making the colors darker. So I'm gonna have to fix some stuff with the code, and then I have to actually update my GitHub. Have like a finalized thing with like all the corrections, all the suggestions you made for me, which are very, very great ones that I wish I thought of sooner. But yes, so then down to our mouse pressed. Right here, we're using this if else statements saying that like if the mouse is pressed on the left click, and if you're left clicking and the mouse is between 0 and 256, or the width of the first rectangle, and it's just within the height of the first rectangle, then it's gonna add random RGB or white, making the image or the color lighter. So if you click on any of the rectangles like I showed you, it'll make them lighter. Let's bring up once again, just so you guys see. Those count. So wait. So yeah. And this goes for how to do this for each of the rectangles. You can just universally do it across the whole entire thing. So I'm saying that if it's left click and the mouse is within these parameters, 256 pixels to 512, which is I believe the second rectangle, and it's between its height, then it's going to add lightness to that color. So do all that for each of the 5 rectangles, and we're doing the same thing. We're doing the opposite for right click. So if you right click, it's doing the opposite, where it's like if you right click, it's between these X and Y coordinates. Then we're taking away those colors. So run it again. Boom. I'm going to do that for each of those rectangles. Now we're getting to the void key press function. And this is gonna generate either a complementary or a monochromatic color, depending on which lottery it is. I believe for this first part, I'm using the lottery. Well, the first lottery is lottery 1 for monochromatic colors. And just in case you guys don't know, monochromatic means it's like there's one color, but it's different shades. That one color for that palette. And complementary means the colors are. It's going to choose a color that's opposite on the color wheel. And so, light and printing colors work differently. I think it's working with light colors. So I mean the color of light. My bad. And the complementary colors for each of those would be like complementary color for yellow would be purple, and vice versa. The complementary color for orange would be blue, and the complementary color for red would be green. So yeah. And then we're initiating this first function, the first integer, the lottery, and it's gonna decide which sort of color scheme to choose from. And like I said, the first lottery is monochromatic, and then we're using the random integers to pick colors. And right here, this fillet adjust. It's just a color modification to help reduce the amount of pure black and white in each palette, making them more like visually appealing. So we're doing it for each of the rectangles. Saying like, oh, this monochromatic one's gonna be like this and that, this and that. And we're adjusting each one too. Then for our if or our lottery 2, for our complementary colors, there's a set pool. We're using all the colors, and we're using for this first part we're using the exact complement or the exact opposite. And then for the next one, we're using a lighter or darker shade of the complement for each color. And the same thing goes again with the other complementary integer right here. Now we get to now I have another else statement right here, and this one's going to help that's variance in our color schemes. And this right here, this random bright, it's going to help choose a number to help decide which RGB value will be 0. It's going to help a lot with the math. And yeah, so if it's 2, then it's going to give us no red, full blue, and there's a limited range of green. And this is gonna this shifts the possibility from the colors. This shifts the possibility of the colors from 0 to 55 to 200 to 55, which is like it goes from a blue green color to a blue green color, and so it gets more like intense going down each rectangle. We're adding more of that. It'll be a bigger shift. I mean. And the same thing for if like the brightness, if the random colors, if the algorithm produces something over 4, then it's going to give us like a random red and this is set limited range for blue and no green, and adding more to this blue from its short limited range makes the reds look more purple, and that's for each rectangle as well. And then finally we get to this last part. And saying if the algorithm makes something bigger than 6, or if it detects brightness bigger than 6, then it has a set range for the red, full range for green, and none for blue. And the shift change for red makes the yellows look more orange. And there's a subtraction of addition sign here for a reason. We're actually going to be taking away from the red, and it has a higher starting value because it produced more unattractive colors if we were adding more to it than taking away. It'd be like nasty greens and brown. It's like brown. It's not appealing colors at all. But yeah, that was a quick run through for the basic premise of the code. I'll try to get it updated so it's fully finished, so you can save palettes and stuff. Hopefully by the end of the week. If not, I'll try to get it done sometime during the fall semester. But I will email you guys once it is there. But yeah, I'm going to run it one more time so you can see what I'm talking about. So yeah, so monochromatic and then both logics working at the same time. Where I said there's monochromatic and and complementary colors. So these two would be example. These three would be examples of the monochromatic ones, and then the complementary ones would be the blue because orange's complementary color is blue. And we do it again. This is the whole monochromatic one, so I read the whole lottery one. Whole monochromatic, and yeah, it's a lot of fun. So yeah, this is my code. This is my project, Quick Palette, and I should be working on it a little bit more. Thanks for listening to me like explain my code. See you guys.